We're here at the Franklin furnace, which was built by Matt and George Moss. Now this would have been where we take the iron ore, melt it down inside the crucible using coal or charcoal, adding a little bit of limestone for the flux, and that's what's going to make the pig iron. Now the chemical formula for making pig iron is pretty simple. 3 to 2 to 1. 3 parts iron ore, 2 parts fuel. In the case of this Franklin furnace, it was anthracite coal. In some of the local furnaces, it was charcoal. And finally, 1 part flux, your limestone. Now the final product is going to be your pig iron. These pig iron bars are the final end of the blasting process. This is what's then going to be taken to the puddling mills and reworked and reconstituted into wrought iron. Now at the blast furnaces, you got a whole host of jobs. You got men up on the floor, the charging floor. They're the ones measuring out barrels full of ore, barrels full of limestone, and barrels full of the fuel, the coal. And they're blasting it in a very specific amount, and they're reading the furnace, and they're making sure the temperature's just right. They're making sure that there's not too much of one ingredient, not enough of the other. After about 12 hours, we're ready to cast. That's when we take our iron bar, and we're going to come in here to the Bosch, the opening of the bottom of the furnace. We're going to poke out that clay plug, and liquid iron is going to start coming out onto this casting floor, which is all made of sand. In the center of that casting floor, we're going to have a central trough, like a gutter, and in that will be our sow iron. Off to the side of the sow, that'll be your piglets. That's how you get your pig iron. It looks like a whole bunch of piglets feeding off a mama sow. When the iron then cools, it's hardened, and then it can be shipped out by wagon from here at the Franklin furnace. So down here on the casting floor, poke out the clay plug, liquid iron out on the floor. Pretty simple process, but also a very deadly one. This iron would be coming out around 2,500 degrees Fahrenheit. Lots of things can go wrong. Explosions if you get too much heat, if you get too much moisture in the stack. You can get fires breaking loose down here. If anyone comes in contact with the liquid iron, trouble. Now, before we would have drawn off that pig iron, we would have had to draw off the slag. The slag is all those liquid impurities that aren't iron. All the other things that were in that sandstone ore, that block ore that we were mining, when that gets heated up, it liquefies in the furnace as well, and it's going to rise to the top like cream on milk. So we're going to have to draw all that slag off the top, and when it hits the sand casting floor, it breaks into these shiny different pieces of different colored glass. It looks a lot like obsidian, which comes from volcanoes. It's basically man-made obsidian. So as you travel around this iron region of Pennsylvania, when you start finding slag, you know you're close to an old blast furnace. Now, making pig iron, you needed something that would heat up the furnace to 2,500 degrees Fahrenheit. A lot of the early furnaces in Pennsylvania were using charcoal. It's baked hardwood. You take oak, chestnut, hickory, maple, different hardwoods, and you stack them in a big mound, cover them with earth, and then you want to slowly smolder that wood and char it. Not exactly burn it, but char it. And that would then be used in a furnace, heated up to almost 2,500 degrees. Now, just to give you an idea of production amounts, it took an acre a day of hardwood to fuel one of those furnaces that ran on charcoal. So you can quickly see how the iron industry is consuming more land than it was able to keep up with. Somewhere around 250 to 300 days a year of operation, a furnace was very quickly using up too much of its land as just charcoal. So that's when the anthracite coal started being used. In the 1830s, 1838, 1839, local furnaces, including this furnace here at the Franklin furnace, was using anthracite coal. The difference between the two processes, charcoal, you don't need any special type of ventilation. Just blast that air in on the fire and it'll heat up hot enough. With anthracite coal, you needed to take the hot fumes coming out of the top of the furnace and recycle that hot air, and what that did is it preheated the fresh air coming into the blast, and that was called a hot blast furnace. So a hot blast furnace, anthracite coal. Cold blast furnace, charcoal. There's a few local furnaces that were using charcoal and did employ the hot blast method. Now, in addition, at an iron furnace, you would have had what's called casters and molders. Now, the molder's job were to take sand and wooden molds, and what they would do is prepare a whole series of molds that would then be filled with liquid iron. So very similar to the concept of making pig iron, but this is to make more specialty products like stove plates, frying pans, farm implements, a whole host of materials. So what you're seeing here depicted, you've got what's called the drag on the bottom filled with sand and packed, and now the wooden mold is placed in the drag, and it's going to take the shape of the bottom half of the mold. After the mold has been placed in the drag, the next process will be to just sprinkle just a little bit of dust over top of it, a little bit of chalk or talc, then to put what's called the cope on top of this. So now the mold is still inside of here, and we're going to place sand inside of the cope. Now this sand would then have to be packed down with what's called rammers, and it would be rammed down on top of the mold from the top now. So now we have packed sand underneath the mold. We're going to have packed sand on top of the mold. And what we're putting now into the situation, you have what's called the vent hole and the pouring hole. So in other words, when we pour liquid iron into this, you need a place for the iron to go in and a place for the hot gases and pressure to get out. So again, packing it in with tampers or rammers. And once everything's packed very tightly, you can remove the two wooden vent hole molds. Going to remove those vent hole and pouring hole molds. And very carefully remove the cope. And if it's packed tightly, the sand should stay intact. So you take that off, place it to the side. Then you're going to remove the mold. The mold will then be placed aside and reused. It's the pattern, in other words. The mold is the pattern that you're going to be casting iron into. Next, you're going to place the cope back on top of the drag. So now you have an empty cavity, the shape of your mold, and now you're going to pour in that liquid iron. When it's time to make your pig iron, in other words, you're going to have the casters and the molders actually collecting containers of liquid iron that they can then pour into these molds. And you'd have a whole series of molds. After several hours of cooling, you can then take the cope and the drag apart and remove your finished piece of cast iron. Molders were only paid by the finished piece of cast iron.
So the second stage of the process is actually bringing the iron ore from the mines down to the blast furnaces like you see behind me. These were structures where they would take the iron ore and actually smelt it down into the pig iron. From there, that pig iron would then be taken into the foundry where it would be finished into a final product of some type of iron that was needed. The main problem, though, was the fact that these things had to actually operate 24 hours a day. So they would actually be working 12 hours a day for 7 days a week for as long as it needed in order to smelt the iron that had been brought down at that time. The blast furnaces were very, very hot. It was really dangerous work. It was something that guys were killed on the job and many times were injured. On an average day, they could actually make about 4 to 5 tons of pig iron. Once they would fire up these blast furnaces, they would run continuously, 24 hours a day, 7 days a week for approximately 3 to 4 months. After that time period, they would have to shut them down so that they could go back in and clean out the inside. On the inside, it looks like a teardrop, and that's actually lined with bricks. So they would have to shut down the furnace, go in, clean it out, and then when they were done with that process, then they would fire it up again, and there we go, 24/7. Very hard work, very dangerous work, very low pay. By around 1890, many of the local furnaces began importing their iron ore from the Great Lakes region, which actually caused many of the local iron ore mines in this area to cease in production. The blast furnaces would last for another decade or two, and shortly after the turn of the 20th century, they began ceasing operation as well. A few of them lasted a little bit longer than that. Some of them, such as the Greenwood furnace, as well as the Glen Iron furnace, continued making pig iron and using charcoal well into the early 20th century.
But thou art mighty, hold me with thy powerful hand. Bread of heaven, feed me